Let us now try to analyze the same circuit using superposition theorem. So in superposition theorem, uh, our objective would be to keep the sources one at a time and try to find out this current I naught, and finally add the value of the current obtained in the two cases. So in one of the case, I have to keep the current source and replace the voltage source by its internal impedance, which is basically zeros. That means I have to short circuit it. Okay, in the other case, I have to replace this current source by open circuit. So that's the internal impedance of an ideal current source. So let's start. So basically, the first thing would be to replace the voltage source by a short circuit, which I have done it here. So this is my circuit now, and now let me keep this thing intact and replace the equivalent of this. Okay, since these are in parallel, I can rewrite or redraw this circuit like this. So there would be a current source and this resistance, 1 ohm resistance in red here shown, and then I have an impedance. Let me call it Z dash. Okay, so if I can reduce the circuit to this form, then I can easily find out the current that would be flowing through this 1 ohm resistor. Okay, so let's start. So Z dash will be equal to 1 plus J times 1 minus J divided by 1 plus J plus 1 minus J. So J gets cancelled. So finally, if you calculate it, you will get this equal to 1 ohm. So that means I naught dash will be equal to 1 angle 0 degrees. Why? So you could see here, if Z dash is equal to 1, then the current that is flowing from here, which is basically 2 angle 0 ampere current, so it gets divided in two parts, and we know that by current division rule that if I've got two impedances connected in parallel and there is I current flowing here, so the current I1 and I2, I can find it out. So that will be given by I1 equals to I times Z2 divided by Z1 plus Z2, and I2 will be I times Z1 divided by Z1 plus Z2. So if I apply this concept here, so I can get the value of the current that is flowing through this 1 ohm resistor equals to 1 angle 0 degrees amps. Okay, so this is I naught dash. So remember, we haven't arrived at the result yet. This is the first step in solving the circuit by the superposition theorem. Now next step would be to find out I naught double dash, and we have to replace now the current source by open circuit, and the voltage source will be there. So for this circuit, let me actually convert this the resistance. You could see here we have got two resistances, one here and one here. Okay, so if I reduce this circuit in this form, basically this, and we have got two resistances, Z1 and Z2, and they are in series. So this Z1 is this resistance, the combination of these two, I mean impedance, and Z2 is this. So 1 ohm resistance in parallel with the combination of these two. Okay, so if that's the case, then we can find out the voltage V1, let me call it double dash. We can find it V1 double dash, which will basically appear across Z2, V1 double dash. And if I can find out V1 double dash, then I can easily find out the current I naught double dash. Okay, so that's the concept, that's the way we will be trying to do this circuit. Okay, so let's try to find out V1 double dash. So V1 double dash is basically equal to 6 angle 0 degrees times 1 minus j into 1 divided by 1 plus 1 minus j. So this is basically the impedance, this impedance Z2. Okay, this is Z2, and I have to divide it by some of the impedances Z1 and Z2. So Z1 is 1 plus j, and plus, I have to write down Z2 again, divided by 1 plus 1 minus j. Okay, I hope you understand how I get this V1 double dash. So basically I had applied the voltage division rule here. So here you could see V, or say V1 double dash, and say this is V1 dash, then V1 dash will be given by V times, if this is V, then V times Z1 upon Z1 plus Z2, and and V1 double dash would be given by V times Z2 upon Z1 plus Z2. So this concept, we have utilized it here and tried to find out V1. Okay, so if I try to reduce this expression, I would get V1 double dash equal to 6 into 1 minus j divided by 4 this much volts. Okay, and then what about I naught double dash? So I naught double dash will be equal to this divided by 1. Why 1? Because you can see here that we have got this 1 ohm resistor. So V1 double dash divided by 1 will give you I2 double dash. So if I divide it by 1, I will get the same expression, 6 times 1 minus j divided by 4 amperes now. So this is I naught double dash. Okay, I had also found out I naught dash here. Okay, so I have to add these two to get finally I naught. Okay, so I'm basically adding these two. So I naught will be equal to I naught dash plus I naught double dash, and that will be equal to 1 plus 6 times 1 minus j by 4, and that will be equal to 5 minus 3 j divided by 2 amperes. Okay, so please see to it that this is the same result that we got when we applied nodal analysis to the same circuit to find out I naught. Okay, now we will try to apply what is called the source exchange method to find out I naught. Okay, so let's proceed. So in source exchange method, basically we would try to use this concept. So if I've got a circuit like this, okay, I can convert it into this circuit. So a current source in parallel with an impedance can be converted into a voltage source in series with the impedance, and the magnitude of the voltage would be the current amplitude times the impedance Z. Okay, so let me apply this concept and try to solve this problem and find out I naught. So in this method, we will try to convert this part of the circuit, this part, by replacing the current source in parallel with the impedance with a voltage source in series with the impedance. Okay, so after I apply this source conversion, so basically this circuit would now look like this. So there would be a voltage source and in series with an impedance, and that would be 1, and this would be j, and this is 2 times 1 plus j. So how I get this? 2 is the amplitude of the current here, and 1 plus j is the impedance. So Z was 1 plus j, so 2 into 1 plus j would be the voltage. So this is, okay, this is, and now I draw the remaining part of the circuit, which is a battery, a voltage source here, and there is a resistor through which I intend to find out the current I naught. There is another resistor, and then there is a capacitor. So minus j, 1 and 1. Okay, so this is our circuit. Now one more thing I will be doing here. So I will try again to reduce this part. I will combine the two voltage sources into one, and then I will again change it into a current source in parallel with an impedance. So I would be making some more changes here. Okay, so this circuit would again be changed into something like this. So there would be a current source and impedance here, and rest of the part of the circuit would remain the same. So this is minus j, this is 1, this is 1, this is 1, and this is j, and this is now 6. This was actually a 6, and this. So I have to add these two and divide it by this impedance. So this would be 6 plus 2 times 1 plus j divided by 1 plus j. So this is the equivalent circuit. Now we have to solve this circuit. So we do it in an another lecture. Thank you.